data science model. Now, super interesting topic, something I came across in my previous workplace at Deloitte. Just fell into that project, and I think it was a very lucky fall because I've never heard of this before or ever been even part of it. So then it made me think, are other testers involved in this area? I started researching and asking so many people, and many of them said, we do know there's a data science area, but we never get involved. So I was like, big question, then how do they test their own work? And how do we trust that everything that they're testing is the right thing? Because obviously we are quite innovative, we are curious, we like to think differently outside the box. So now I was like, this is the right kind of topic to talk out there about. And that's what I've been sharing for the last few years. I started speaking actually in 2020 when COVID started. And I thought, I don't want to get stage fright. So this is the right time for me to start virtually and see how people respond to it. And they really gave positive remarks to this talk as well. So here I am today presenting here with BCS. So I've graduated with a BSc Honours in Computer Science. I fell into testing, so my first ever job was for a consultancy called CGI, where I was just someone rang me from the consultancy saying that there's a project about testing, and I was like, right, testing, did I ever even study this at uni? Answer is no, we never studied it. So I just fell into it and I learned on the job, which was really, really good. And today, nearly 10 years now, I've been testing, so I'm a test manager now, and really enjoying that kind of gradual increase of roles and trying to understand from very different perspectives. So as you can see, I've worked in various different industries: oil and gas, transport, financial services, and consumer goods. Currently airlines as well. So it's super, super interesting. And some of my hobbies include dancing, yoga, teaching, and baking. I think today, for me, it's the most special presentation because, of course, it's part of BCS, but my parents are here watching me as well. So it's really special to me. Okay, so I'm going to divide our session today in 3 different parts. So what is a data science model? I will take you over some background knowledge to help you gather some insights of what this really is. The process around it, how do we test a model? Because a model can be very different. It can be something that could be a bit random, but how do we know the randomness is the right randomness? And some tips for you to take away, which I learned through the complexities I face. So potentially, if you do see them, then you know roughly how to react to that. Okay, then. So I really like this stat here. So currently 80% of UK businesses are looking for data scientists or seek data consultancy. So this actually calls for all of you out there. Are we testing it? So we need to focus into that. And then IBM anticipates that data science will account for 28% of all digital jobs by 2020. We're in 2022 and I keep hearing data science a lot. So it's lucky sometimes when data science teams are being created and you get asked to, could you come and look into a strategy of how should we work around this, or could you come and help us think around testing? I feel really, really privileged because otherwise it's data scientists testing their work and we just leave it to them. So think about these areas. If you have these areas in your offices right now or in your projects, I would suggest find the right name to contact and see how they're testing. Okay, so what is data science then? So it's a set of tools and algorithms to unveil hidden patterns from raw data. It allows decisions and predictions to be made. The aim of making informed decisions, basically allowing us to have a much more, how shall I say, give you a bit of a predictive way of seeing things, but not 100% that this profit will happen, for example. It's just a prediction. It's not 100% true. Also, data science is a more of a forward-looking approach, an exploratory way with the focus of analyzing past, current data to unveil what could be the future. With predictive analytics, which is your first buzzword of the day, organizations can find and look into patterns contained within data in order to detect risks and opportunities. So I will explain predictive analytics a bit later on, where I've actually drawn out a little schema or a flow, and I'll explain a bit more to you then. So what is a model? So I thought, let's give you an analogy rather than getting too technical. So imagine you are commuting into work and you basically want to sit down into your car and you want to put the aircon on, a nice radio station on, your experience of driving, right? That is your data, your experience. And then the compute side of things is when your brain is trying different patterns. So that's the main bit of a model. Now, how do we use that as humans? If we get onto the road and we see traffic, we try and maneuver the car so that we can skip this traffic. We'll try and find the next left or right and just U-turn, try and go through a different direction so we can get a bit sooner to work. So now the model bit. This is an equation of data inputs affecting target values. In this case, the target value is how soon can you get to your workplace. If you do get to your workplace in good time, your model is optimized. It's been trained, the parameters are accurate, and it's actually doing what it's meant to be doing. If you arrive late, something doesn't seem right. Something's an anomaly. So we're trying to understand what that could be. Another example that I could give you of is, imagine for a manufacturing firm, you can actually check what they sold last week and check what if the same assumptions were used, what could their potential future sales could look like. And that's basically projects that I was involved in, manufacturing firms and their factories, to help them produce their product in a quicker, faster manner. Even though if they're international, how do we print out those language tags quickly and make sure there's less wastage? So these are a few examples of what a model could be like. Something for you all to remember is a model is a what-if kind of a product. If a customer uses the parameters for the model we suggest, or the company has portrayed, then the business, this is what the business could look like if you use those parameters. On to my second buzzword of the day, genetic algorithms. So models do use genetic algorithms, and this reflects the process of natural selection, where the fittest individuals are selected, and it's inspired by Charles Darwin. Also, models produce some indications that are being used as a guideline by our clients. And what do we do as testers? We test against the expected outcome, just to make sure that what the model is producing is the right thing. And we try and break it where we can, because it's better if we break it than the client goes and breaks it. So it's useful to kind of look from those perspectives. Now, the benefits of a data science model include helping you craft better decision making, identifying opportunities. Actions are based on trends to help define goals. Data-driven evidence, so tons of data. There's too much data going on. Identification and refining of target results, and mimics real-life scenarios. It's not 100% real life, but it will give you as close as it can, so that you can work accordingly and you can give those results to your clients to perform better. So, with a data science model comes a lot of data, as explained. But this data can be divided into various different parts. Structured, for example, which is like an Excel file, so adheres to predefined data models. You can also have unstructured data files, which are videos and audio. So not organized as such in a predefined manner, and it can have some irregularities. Semi-structured data is more of the JSON XML, which is something that a lot of data scientists and data engineers use, because this gives us a file that we can provide to our clients and tell them, could we have your data in this manner, so that we can ingest it through our model and see the results. And then you have metadata, which are more like photographs, and you can understand more from it. Where was it taken? When was it taken? And can be considered as structured data. So this is a little diagram that I've made, a flow, which can explain to you how really it looks like in the real world. So you have a database, you have some logs, your data comes in as raw data. So that's your data extraction phase. Then you have some features that obviously we want to run it against, some requirements. And that's your feature extraction and pre-processing. So the model is now trying to understand what I'm trying to do, what am I actually trying to deliver. Then you have your learning algorithm, which earlier I did explain a little bit, but I'll explain better to you now, which is predictive analytics. This is the use of data, statistical algorithms, and machine learning techniques to identify the likelihood of future outcomes based on historical data. And organizations use a lot of predictive analytics today to sift through current and historical data and detect trends and forecast, basically, any events and conditions that should occur at a specific time and based on your parameters that you provide to them. Then, after the predictive analytics has started working, you come to the model bit where you can put your genetic algorithms, which can cause a little bit of randomness. So now this is the exclamation mark point where, as a tester, I was thinking, why do I keep seeing different results every time for this specific table? It doesn't seem right to me. And started getting really worried that, are we testing the right thing? So that's where obviously relationships with your team members, your colleagues is handy, where you can speak to your data scientist and understand more about it. But I'll touch base on that a little bit later. So when the genetic algorithms start working, I'll give you another example. So say if I was to provide money on credit to someone, then the probability of customers making future credit payments on time is a matter of concern to me. I would not want to give a credit card to someone who I feel will not pay back. So you can build something like this for that customer and perform predictive analytics on the payment history of the customer and predict if the future payments will be made on time or not. So with the predictive analytics playing here and the genetic algorithms, you get future-like looking data at the end of it. And basically, you are trying to test through it. You're trying to test the ingestion as well, making sure that the files that the clients are providing to us are the right size, are the right information, because sometimes what happens is when this data comes to us, it can be raw. So we might have to anonymize it. When you anonymize it, you're very easily changing file sizes as well. So that's something to point out as well. Something to be careful of is the elephant in the room situation. In many situations in data science or any other projects, I'm sure you faced this, where it's impossible to understand what we are actually doing, or there's loads of information going around and we don't know what this is. So I would suggest, before we fall into this trap, it's best to sit down with everyone and have your right requirements written out, because if you have them right from the start, you can avoid this. Again, when it comes to planning, brainstorm possible solutions. Think from the various different people's mindsets as well. Do the Three Amigos session. So think from the developer's side of thing. How might the developer build a solution that will help solve the problem? Think from the testing side of things as well. So what about this? What about that? Like the edge case style thinking. What could possibly go wrong? What are we not capturing that we should? Any dependencies, any risks? And how could I implement this and it may not leave a negative impact on the full product? So these are important things to think about. So let's get started. I'm going to show you a little bit of a process. So it's not a demo, but it's just how I worked through it. And then you can see how you may be able to bring that in your workplaces. But before we get started, just wanted to mention that obviously a model could be off the shelf, but a model could be custom made as well. Depending on which one you choose, the processes should be made accordingly. Consider on training your model. Imagine by training, what I mean is your input data run your model and see the expected outcomes. Run it various times and try and understand the shape of your data. By shape, I don't mean triangles, circles, squares. I mean, what are we trying to deliver, really? What's the shape of this data? And also, as I said earlier, randomness, which the data scientists call stochasticness, is quite prone if you are kind of doing a custom-made model, where for me and all of you, 5 plus 3 would be 8, but certain data you might see as your outcome would be 8.000065, and you'll be thinking, this is wrong, this doesn't seem right to me. But an anomaly could be something that we can all take as, we can take it ahead rather than say that this is definitely an anomaly or a bug. But I'll explain a little bit about this in a bit. Okay then, so it's important to verify the data set to use for the model. So of course, if you're working with data science and you have a couple of clients, it's important to see what's the data set like. Are you providing us JSON files, or how are we working with this? Validate your input versus output data results and try and see if they are looking realistic or not. Because sometimes what happens is you may end up seeing some irregularities, or the model remembers something from the previous run. You want to completely clear that all out. Test the areas you're certain about and uncertain about with the thresholds. So this brings me nicely onto the stochasticness, the randomness, where we are uncertain about things. So how do we know that this will 100% work? So I worked with the data scientist to tell him, I keep doing regression testing, I keep doing all of these checks, but I'm not sure if I'm doing the right thing. So as mentioned earlier, put your hand up always if you are not sure about things. It's okay, it's a safe space. And luckily, the data scientist said to me, we should work on a process that will help us define this better so that you don't get confused. And we came up with something called thresholds. So any values that were coming as the 8.00065, if it was within the 5% boundaries, we would approve it. But anything that was going above 5% change from the previous Delta run versus the current new run, then we would actually look into the model and check if the parameters are faulty or the model's not working appropriately. Also, again, if you're working in a very critical environment, maybe a bank or something even more critical, I would say keep your thresholds to a very minimum, 0.5% to 1% or even less than that, so that you can capture the best values. But that's what happens when you test the uncertain areas. Also, make sure the data pipeline works as expected. Sometimes the data can be lost. They can be duplicates as well. So make sure if this is happening in your pipeline, why is it happening? What is wrong with the infrastructure that the data is being dropped somewhere? Try using different parameters. So don't just put what the field says to you. Try and play around with it, see if the model still runs. Because when I was doing that, the model was still running and it was providing the results where it should actually give you the right error messages. So we had a front end, a system pushing the model in the back end to run and provide us with a dashboard that we would provide to our clients. But play with these parameters. It's something that we learned very earlier on as test analysts, right? Boundary analysis, edge case style testing, break the parameters, see what happens. And explore the model at the end of the day. Try and do some charters. Think about ways of testing it differently. Go in without planning and see what you can find. Because as I explained in previous places, is imagine Swiss cheese. It's got quite a lot of holes. So then you might have a bug just sat somewhere that you might not have picked when you're doing your usual regression testing or feature testing. But you might find it when you go with a clear mind and it's sat there all this time. So try and do a lot of that as well. Okay, so some more about testing. So when it's a new feature that you're working on, work on a test plan with a data scientist. Like make your test plan, but just get them to proof check that this is what we mean so we can avoid the elephant in the room situation. Consult the results with the data scientists for more conciseness as well. because they are the only ones who understand their algorithms. And here is where the imposter syndrome kicks in for testing, where we might be thinking, oh, do I need to study maths to be in this team? Not really. It's all good as long as you have data scientists who are helping you. Some of them will actually provide you some queries that you can run with as well. So it's all good. Make sure the logic is tested via unit tests, because I keep hearing and seeing that data scientists avoid creating unit tests. So we want to push more for that. Try, if you don't see it in your teams, push for it, because it's important. If we have a unit test, if someone wants to revert back to things, how do we really know this is working or not? Run the model prior to the new feature and after. See what difference it made. What improvement did it give? And as I said earlier, exploratory testing. When you're doing regression testing, I would suggest have a delta run already that you might have created in your first ever model run, and compare your current run with the historic run that you made to identify trends and comparisons, because this will help you understand if you are on the right track or not. Remember, some models can have some sort of randomness, but that is okay. Even with all the advancement we have in technology, sometimes randomness can be there, but I would say embrace that randomness and try and see how you can improve it, or if it's the right sort of anomaly or not. Again, no equation for the best answer exists. Rely on a good enough and fast enough results. And as I've said earlier as well, even with the advancement of technology, 100% automation right now for this may not be achievable. It's something that I get asked a lot. Can we automate the whole process? You may be able to automate some parts just to give you that quick confirmation that the pipelines are working fine in the back end. But for the model to give you the right details, how do we really know that my automation understands my model? It's very different. So we're not there yet, but slowly, hopefully we get there. So some useful questions to think about when actually testing a data science model is, what is an acceptable test? We may be able to go into a system and test everything, or maybe test a small part, but what is really the right kind of test we should do? Has a run completed and nothing broke within various stages of a model? And if not, can I continue having that confidence, or something might happen in the future? So we need to think about that as well. Also, have we found any anomalies? If we have, do we have a threshold in place? If not, can we put a threshold in place? Did we drop some data? If we did, where did we drop it? And have we been dropping it there all the time, or this has happened in other stages as well? How do we know that we have produced the right results is the most important one, because it's a data science model. It somehow predicts something, but how do I know it's 100% doing the right thing or not? We can't tell. We need the support of a data scientist and data engineers to help us. Again, how accurate are my results? As a tester, obviously you have loads of questions, and it's okay. I would say no question is a silly question. Any question you have, just ask in your team, whether that's in a stand-up in the morning, in your planning sessions, in your feature planning. Ask as many questions as you like, because that's the only place you will get the most information from. And what is an acceptable deviation? So if you've set up thresholds, you will know what's an acceptable deviation. If anything is above that percentage, you know that it's potentially an anomaly, and you need to revert this back to your data scientist. Okay, so this is a little bit of a practice one. This is just a data file that would just be ingested into a system. The model will work on it with predictive analytics and genetic algorithms, and then you will see something on your dashboard. So this is literally what it looks like, essentially. So questions you can ask are, how many birds have we counted in each and every area in total? How many do we expect in area B? How many do we expect in all areas by next year? These are the kind of things that we start thinking as a tester. We don't think about now. We start thinking about what are we expecting in the next few months or years or weeks. And that's where the model comes in handy. So this essentially is what it looks like in a simplified manner, but it's really, really in-depth and loads to learn from it. But as I said, you don't have to be a mathematics pro to get this and test this. Some complexities that I came across was how can we mimic the client data? So either you spend some time and have a golden data set that can capture all features. Now that is not possible because every time we have new features coming in. So how much of the data will keep changing? Unless we have a project and we have an end of that project, then we know for a fact, this is the data, these are the features, and there's not going to be any more features, then I can mimic it from that. So we need to understand around that. If we anonymize, we need the file sizes to match to the client files. So this is where I found a fault, where the developer went and changed the file size to a minimum and maximum on the system, on the dashboard that we could upload, but didn't let the team know for some reason. Now the clients are uploading their files and they said that we can't upload our files to say that it's reached a maximum. And I told them, it can't be true because I just put up an anonymized file of your data. Little did I know, when I anonymized it, the file size became half the size. So we need to think about that too. Again, there's loads of data policies. So it's always good to kind of respect that, GDPR especially. And the model's complex. I don't expect any of you to know the A to Z of a model because it's not possible. Avoid any knowledge silos as well. It's an area where you could potentially get a lot of silos because it's just so complex sometimes. How do we actually work with silos? Whatever you learn, any demos you do, put them on Confluence or somewhere where someone else can see it. And remember, dependencies. It's always best to capture your dependencies before they catch you. So if you are thinking about what are the risks and assumptions, think about what this model is impacting, different areas, different pipelines, and try and work accordingly. Okay. Some tips for you to take away. I don't know why I keep saying tips, but understand the data from a business point of view. Why are we trying to provide this solution to someone? And how is it helping them? Don't derail. Stick to your requirements and whatever you've planned, because that's the only way we're going to deliver together as a team. Sorry about that. Review and analyze any sort of specifications, requirements, documentation, any analysis that you do, and basically give the best that you can from that analysis to your team. As testers, we are really, really good at that. We try and get to the root cause very quickly and try and understand things. We come up with risks really quickly. So think about that. But I'd say assumptions. Don't come up with so many assumptions because they limit your scope. They make your what do you call it, your testing really, really complex. Thank you so much. Thanks. Yeah, they limit your scope and they make it really tricky because if I'm going to come up with like 10 assumptions, that's going to basically confuse me and the team. So limit your scopes so that you can come up with the right kind of details and don't go too much out of your zone because we'll start derailing and then the elephant in the room starts and all of that drama. So let's avoid that. Be ready for discrepancies, it's possible, but you can embrace some of them because we've got thresholds. By providing these statistics to your clients actually, and employees, because we are using it, we're seeing what it is, what you're doing is you're creating a smart, savvy team that can use these insights to drive more business. So you're not just making this model for one client, you're trying to use these ideas and sell it to more clients. And say, for example, if it's a manufacturing firm, for example, KitKat, if my model is so successful, I can provide it to another company, Nestle, other companies around the world, Cadbury's, see how they feel about it. So you're creating more business. And yeah, what does this leave me with then? A tester who's come and learned a bit of data science validation, leading to a hybrid tester. So we are using our testing capabilities and whatever we've learned to try and understand data validation and see how that is going to help drive more business and making sure that the results we are providing are accurate ones. Some tools that I used and that I'd like to share with you is SQL. Again, don't have to be a SQL pro. Sometimes the data scientists also help you with that, so it's all good. Statistics, don't have to be a mathematics pro. Sometimes data scientists tell you what this means and why they've used this statistical algorithm and the reason behind it. Excel, I used a lot of Excel. I want to run away from Excel. It's not possible. Developer tools, because it was a front-end app, you can try and test for accessibility or other things from front-end and see if the colors that the UX designer is choosing is the right one. There may be someone in our team who might be colorblind. How do we deal with that? Or in the client's side, there might be someone who might need some support. So that was checked as well. And Miro board to share your thoughts and have this kind of 3 amigos session, discuss things rather than keep them in silence. So as a little summary, remember to do edge case testing and exploratory testing in this area. It's super important. Make sure the model and accuracy, precision metrics are met. So work with your colleagues, collaborate as much as possible. Make sure the model can perform at a scale with new features. So the model should not only run for second or third sprint, it can keep running again and again and again whilst we're in sprint 100 and we've had like so many features on top of it. Shouldn't break. And make sure it's maintainable throughout. So yeah, that leaves me with an insightful session today here of what I have tested and how I've done it. I hope you found it useful and feel free to reach out to me. Thank you.
Presenting while you're feeling under the weather as well. I have a question. I'll start with a little of the questions, which is about the randomness. Are you talking about randomness between testing 2 versions of the model or running 2 identical tests immediately after each other?
I'm talking about the randomness for one model only.
Okay.
Because it's custom made, it's not off the shelf. The algorithms sometimes use predictive analytics or genetic algorithms can provide stochasticness. So we just need to make sure, this is something I learned on the job, but because I've told you this, if you will ever use a custom made model, just ask the randomness question before, so you are ready for it.
We have a lot of elasticity in our models, so the same user case can be run through the model and get a completely different price because our model is quite elastic.
Is that using genetic algorithms as well? Yeah, I haven't tested genetic algorithms.
We have a lot of individual optimization as well in our data models. So.
And the data set, like the base data set is the same?
Yeah, in theory, you could just price flex like quite a lot. The elasticity has like, well, they set their elasticity usually, but it can vary quite a lot. So one static regression case could just never align. So that's why the tolerance usually comes in. I did have a question, if that's okay.
Yeah.
How do you, in my company, we have a lot of complex data models, for example, but they're often seen as complete black boxes. Like it's kind of a company policy that we just treat them as black boxes, don't worry about it. How would you suggest we push for a more kind of open conversation with, can we start looking to test these things? Because at the moment, it seems to be a bit of out of scope kind of world.
Yeah. And I would say it's important to test them because you never know, there may be an incident caused by those black boxes and we're not testing them.
I think as well on that is like we've noticed that a lot of the data models will only get, optimization, for example, only get touched like once a month when they've got enough data through. So if there is an incident in it, I imagine it could be quite disastrous, right?
Yeah, because none of us have idea and we've not ever tested it. So I would suggest start coaching your team. and try and explain to them what the potential risks and dependencies are with those black boxes. Again, use the brains of an architect here as well, and try and explain to them why should we test this, and what are the implications with it if we don't test it. So the way I would go ahead with is do your research, work with an architect, and try and provide your research and the inputs from the architect to your team, and try and create some sort of features in the backlog then to start doing some regression tests on those black boxes, because that's the only way to save yourself from an incident happening. And we all know when incidents happen, there's reports with it, there's ad hoc meetings with it, and it continues and continues. So I would say research coach your teams about it, because maybe for a manager that is not priority, but the day that mistake happens, it's going to become chaotic. And call it chaos testing. Because we are not waiting for a chaos. Chaos can happen anytime. So try and work that way.
Thank you.
Yeah.
You've clearly learned a ton about this already, but what do you think has been the biggest challenge going into it for you personally?
Understanding these algorithms, understanding how a brain of a data scientist works. It's too complex. And I was like, I'm just a tester. You are somewhere else. You are in another planet. We need to match somehow. So sitting down with them, understanding, speaking to them just over coffees, they probably were like, she's pestering us, she doesn't go away. But you need it. You need it, because how else are you supposed to give the right answers? And how else are you supposed to respond to changes and give them a real estimate of what the testing could look like? So that's been the biggest thing for me, understanding it. And I know that if any of you starts on a data science project tomorrow, it will take time. And give yourself that time, just as mentioned before. Try and create that safe space. It's okay to not know. It's fine.
And on top of that, since you're mentioning there can be elasticity and numbers can vary, how do you approach automating something like that? Is it possible? Do you adhere to, I guess, the thresholds and kind of make sure that results? You
can add those thresholds as an automation piece. Basically what we did a very simplified version, because every time we got data from these files, there were about 18 files. Now, anonymizing 18 files took me half a day. So every regression doing that is not possible. What we did was we automated both files to see what the difference is. So similarly, using the same logic, you can try and see the difference between two results. And we actually saw that that file was always getting more than 5% in every 2-3 releases. So 2 releases, happy days. 3rd release, oh God. That kind of situation would happen. And with those 2 file comparisons, we'd see exactly what it is, and then it would come down to a model issue.
Great. Thank you.
Good.
So now you've broken into the world of the data scientist, and you've obviously got a team of testers that were doing normal projects, let's call them. What skills would you say that your team of existing testers now need to have as you start to do more AI? What extra skills would you say over and above the core tester skills?
I would say continue doing research. There's a lot of information out there for AI. Attend conferences. That's the best place, because you start speaking to people and you never know, you may take a solution back to your work next day. So I would say keep up with the documentation out there online. Learn about these things. You don't have to understand AI or data science from A to Z. You can just understand, what is the use of this? Why should I use this? And then with that mindset, grow your mindset a bit more towards working those projects and providing the value there. So I would say read a lot. Podcasts, there's loads of AI podcasts today. I've spoken in many podcasts as well. If you search, you should be able to see. And it just helps, because I didn't have that. I just learned it on the job, but now you can go and learn about it. So I would say read a lot, listen a lot, maybe even practice a lot online. There's a library, which I can't remember right now, but there's like company data on it. Coca-Cola's data is there. You can actually go and do modeling with it. So I'll try and find out and probably provide it to you so you can do it everywhere. But that was super useful, because I just asked the data scientist and he gave it to me. He goes like, practice with this if you like. You're not a data scientist, but you can be one day if you do this. So yeah, I would suggest that.
My question follows quite nicely from that anyway. So you said you're a test manager now. I don't know if that's in a project test managing kind of way or in a line management and career development way, but given you're so passionate about data science modeling and testing, is that something you encourage your testers to do, or even more than encourage, is it actually part of an active test strategy?
I actually told my head of, I'm only going to take the manager role if I can still manage my data science area. He said, fine, I'll do that for you. Because it's just something that keeps my knowledge going. And he said, it's going to be too much for you. I was like, no, it's not. It will keep my knowledge going and I need it. So I do speak to the testers in those teams, and that team is now growing into 3 more teams. So it's just resourcing that, understanding their projects. Data science is a world where sometimes, a project may start right now. Within 3 days of inception, they might be like, it's a fail, it's not going to make revenue, cancel it. So we've put all our brains into it. We've got test plans, we've covered definition of done, but it's ended really quickly. So that can happen as well. So be careful of that too. Don't let it overwhelm you. But there's so much that happens, and I do let the testers know that, if you need a course or you need some sort of training to be done, just tell me, because I'd rather you learn about how to use something rather than just working day in, day out. So support them, nurture them, because that's the only way. And sometimes it's so overwhelming. Just tell them, look, you know what? The other day, someone came up to me saying, I've got a free kind of half a day. What do I do with it? I said, learn something or chill out. You tomorrow, after tomorrow, you might get another project and you're going to be so busy. So just either use it as a learning day or use it as a relaxed day. And it's fine. Yeah. So I hope I answered.
Is the tool you're referring to Cackle?
Yes.
Yeah, Cackle is a website online where you get machine learning challenges, data sets, and things like that. It's really good.
That's it. It's really, really good because loads of company data is on it. I don't know if it's real or fake, but you can play with it a lot.
It's like a competition thing, isn't it?
Yes.
Someone said that they were like recently onboarded someone. They said they were like top 100 in the Cackle and go to competitions in it. So
yeah, but if you want to build like a classifier and want a bunch of data sets that you can practice on, it's a really good place to go.
Right. Okay.
Yeah, that's really good actually. It will look a bit of a wishy-washy thing for you as a tester because I was like, what is this? But maybe look at some YouTube videos and see how to use it. And if you have data scientists and they're free sometimes, just tell them, can we have a one-to-one? Can you help me do this? And they're really helpful, to be honest. So.
Okay, so just actually a couple of comments. It would be remiss of me not to plug the BCS book, AI and Software Testing at this point, which does cover these topics. And ISTQB has an AI and software testing certification as well. And then finally, don't take this from me, talk to your company lawyer, but the EPDB, the European Data Protection Board, ruled last week that testers can use personal data, production data, for the purposes of software testing now. It's now, after many years of not being allowed to do it, it's now legal again in Europe. And in the EU's AI Act, it also says testers can go and get more data from their users, like race, sex, gender, age, sensitive data, in order to improve their testing for discriminatory outcomes. Which was quite interesting points around data policy that relate to this.
100%, because right now at EasyJet, and we were thinking, what do we do? Because it's GDPR, can't be using client data all the time, but it's okay though.
Check with your lawyers. Okay, so thank you very much, Laveena.